In this video, I'm going to be going over scenario 4, which is asking the question, if I bring a positive acetate strip over to the pith ball, they were initially attracting one another, but once they come into contact, why do they repel? All right, so let's start from the beginning. We have an acetate strip. It has 10 atoms, so 10 protons, and it has a charge of positive 4, which means I need to subtract 4 electrons, which I did. And since it's an insulator, its charge is going to be localized in one area where there was that point of contact. Let's say it's the top right here. So my acetate strip has a positive charge, and then my pith ball is a conductor, meaning the electrons can move freely throughout the object, and it has 10 atoms, so 10 protons, and it's neutral, so the exact same amount of electrons as well. Okay. Now, in the previous video, I talked about electron shifting, which absolutely happens, but for simplicity's sake, in this video, I'm going to be focusing on the before, so what I just described here, and then once they come into contact, what's going to go down. So let's just put them in contact right away. I'm going to have the positive side of my acetate strip touch the conductive pith ball. Now, on our chart, it talks about electron affinity, but that does not come into play here, because that's only going to be for when we're charging two insulators together by friction where those electrons go. In this case, I have a conductor. Not only that, but I have a higher concentration of electrons here on my pith ball compared to my insulator. And remember, a general rule of science is that nature likes to be chill. So electrons want to spread out and even out. And since this is a conductor and it's in contact with this acetate strip on the positive end, electrons are going to want to do just that. They're going to want to spread out. Now I've only moved 2 electrons over, but you'll notice that evenness that the electrons wanted to be at, that's actually already been accomplished. I have 8 electrons here, and I have 8 electrons here. So there's an even amount of charge. Right? So electrons are not going to want to move this way. They're not going to move that way. They're happy exactly where they are. Right? One thing to keep in mind with the conductor is, since this is a conductor, even though the electrons may have jumped from this side, these electrons over here, they're next to each other and they repel each other. They want to get away from each other. So they're going to kind of spread out. The electrons will. Maybe I'll have this electron move over here, this electron move over here. Really what I'm trying to get to is this idea that with a conductor, the charge is spread out. And it's a little bit tough to show with a conductor, or with only just 2 electrons missing. Right? But by having my electrons missing here, it kind of shows that charge is spread out. It's not just that positive charge is just not in one area of my conductor. Right? So now my conductor, my pith ball, has a positive charge. Right? There are less electrons on this object compared to protons. Right? And my acetate insulator is positive still. So even though electrons move over, right, it's less positive than it was before, but it still has less electrons compared to protons. It's also positive. So whenever you're charging by contact, your objects are always going to end up with that same charge. Right? So now we have 2 positive objects. Right? Once they've made contact, all of a sudden likes repel. So these 2 positive objects are going to repel from each other once those electrons have transferred over.